On May 6, 2024, a group of researchers from the Royal Astronomical Society claimed they may have found evidence of alien megastructures called Dyson Spheres, named after physicist Freeman Dyson, who introduced the concept in the 1960s. These hypothetical megastructures would wrap around stars to capture all their light energy. According to Dyson's theory, these structures would be built using materials from dismantled planets within the star's system. Alien civilizations could use Dyson spheres to harness millions of times more solar energy than what we have on Earth. However, this system isn't perfect. While a Dyson sphere captures radiation from the star, it also releases heat from its outer surface, meaning a star surrounded by a Dyson sphere would appear to have an unusually high amount of infrared radiation. Recently, astronomers identified 7 stars within 1,000 light-years of Earth that emit an abnormally large amount of infrared radiation, marking them as potential Dyson sphere candidates. If any of these stars are actually surrounded by Dyson spheres, it would indicate the presence of Type 2 civilizations in our galaxy, which would be a revolutionary discovery. Our sun generates energy that is 100 quintillion times greater than that of our most advanced nuclear reactor. So imagine if a civilization could harness that much energy. They could extract fusion energy and gather raw materials from multiple solar systems, influence the development of life, travel between stars through warp drives or wormholes, and communicate over incredibly long distances. They would also be capable of manipulating stars and terraforming planets, making them suitable for life. Such advanced capabilities would greatly reduce the risk of extinction, preventing or controlling threats like ice ages and global warming, making sure that their planet remains habitable. In essence, they would have complete control over their home planet and possibly others. It has also been suggested that a Type 2 civilization could be capable of starlifting, meaning that they can move stars. One way to do this is by using a stellar engine, which is a kind of Dyson structure that partially surrounds a star and uses its light and gravity to move it, even reaching very high speeds. This could explain why some stars move very quickly. A Type 3 civilization could do these things, but on a much larger, galaxy-wide scale. These galactic civilizations could build things to keep galaxies from spreading out too much. They might find ways to use the power of quasars, which are very bright centers of large galaxies powered by supermassive black holes. If a civilization could somehow manage to harness the energy of the hundreds of billions of stars in our galaxy, who knows what they could do? They might achieve instantaneous travel, create entire universes, or even exist as beings made of pure energy. But with great power comes bad actors. Just as on Earth, not all individuals or groups may use their power for good. In such an advanced civilization, the potential for misuse of energy and technology could be frightening. We could have a galactic empire type scenario, but instead of a simple Death Star, they could manipulate entire star systems, or even weaponize entire galaxies. But if such civilizations exist, where are they hiding? Why can't we detect them? And if Type 3 civilizations are too advanced to detect, what about Type 2 civilizations? Intuitively, if you start to build around a sun to absorb its energy, you block the invisible light that it emits, and as a result, it starts to fade. However, you won't be able to just take the energy from the sun and make it disappear. It transforms into other forms of energy, like heat. In a light bulb, when you turn it on, it uses electricity to produce light, but it also gets hot. The use of that energy not only produces light, but also generates heat. If a civilization has managed to completely enclose its host star, the light would be absorbed by their solar panels. This would cause the star to gradually fade from visibility and eventually appear as a red glow in infrared telescopes. As a result, those searching for Dyson spheres look for increases in these wavelengths, known as infrared excess emissions, or IEEs, within the light patterns of distant stars, along with weird radio signals, atmospheric greenhouse gases, and artificial light. This is exactly what the recent study was investigating. The researchers used a computer program to search for IEEs through a sample of 5 million objects and found 7 promising candidates. One could say that these infrared emissions might simply be from gas clouds containing dust that have been heated by radiated energy. However, the study does state that it only looked at M dwarfs, meaning that the usual astrophysical processes, such as warmed gas clouds, cannot easily explain the unusually high levels of infrared emissions observed from them. But this doesn't particularly mean that those stars are surrounded by Dyson spheres. Natural objects orbiting a star can also produce similar readings. This could include star debris, an asteroid field, or something similar. When a star is forming planets, there is often a large ring of debris around it. Over millions of years, this debris gradually comes together to form planets and other celestial bodies. In a recent study, a team of astronomers took a closer look at the 7 candidate stars. They discovered that 3 of them are near a special type of galaxy called a hot, dust-obscured galaxy. These galaxies are surrounded by large, thick clouds of dust, which are very good at emitting infrared radiation. Therefore, the astronomers suggest that for these 3 candidates, the extra infrared radiation comes not from the stars themselves, but from the warm dust. As for the other 4 stars, the researchers believe that the similarities in the light emitted by all 7 candidates indicate that these stars are also likely hidden by hot, dust-obscured galaxies. However, we don't have detailed enough observations to confirm this for the remaining 4 stars. But let's assume we are optimistic and those 4 stars are indeed Dyson spheres. Intuitively, there are still some problems. Firstly, to build a Dyson sphere, you would need an astonishing amount of materials. For context, our sun is so large you could fit about 1.3 million Earths inside it. And if we were to collect 10% of the sun's energy, a surface area equal to 1 billion Earths would be required. Our solar system only has roughly 100 Earths in solid material. Therefore, an advanced alien civilization would need to dismantle planets from around 10,000 different planetary systems and transport the materials to the star to construct their Dyson sphere. Even with the lightest possible design, this would mean about 100 quintillion tons of material. Then they would need the energy to actually put the parts together and deliver them to their positions around the sun. But historically, Dyson spheres were based on the idea that advanced civilizations would have immense power needs. Dyson never explained what all that power would be used for. It was just assumed that advanced alien civilizations would need it for their activities. However, our global energy consumption has slowed significantly over the past 50 years, especially in the last decade. As we advance, new technologies are focused on improved efficiency and lower power use. By the time humans are able to build Dyson spheres, we will likely have discovered better ways to obtain energy than to take it from a star. It's also worth noting that this study covers stars only within 1,000 light-years of Earth, which is absolutely nothing compared to the Milky Way galaxy's span of 100,000 light-years. This means that there are hundreds of billions, maybe trillions of planets out there in just our galaxy. So while it's very unlikely that Dyson spheres are hiding in our galaxy, the opposite can be said about the existence of life outside of Earth. It may even be inevitable.